So yeah, just to give you like a bit of an overview of how we're going to do it. So Darren will give like an introduction to Catalyst, what it is, and a bit of background about Atlas City and where the company came from. And then Pauline will give you an overview on the more technical side of things. So this is kind of like the first one of these events where we're just reaching out to the developer community and just kind of snowballing from there really with the kind of interest that we'll be getting around what we've been building and the innovations that we've had. So I'm quite happy that we're starting it now, because it should be an interesting time over the next few months as we go through the rest of this year for us. So Darren, if you want to carry on.
Yeah, sure. Okay. You do slides. Okay, before I get started, can I just check how many people here are developers on blockchain or DLT? So, okay, so a couple here, and a few more at the front who aren't putting their hands up. So, what about .NET developers? How many are .NET developers? Okay, so more .NET developers. That's good. Okay, so I'll give a bit of a background actually to the project before we start the slideshow and the company, because that kind of is related to my own background. So I'm a .NET developer myself. So I was working 10 years with Microsoft and Microsoft partners, so working on operating systems, software, and then after that 10 years in consultancy. So BAE, Applied Intelligence, UK Gov, UK banking services. So I'm very much a .NET guy. Now, back in 2012, I got pulled into a project with the European Commission, and it was really looking at the application of blockchain in utilities and smart cities. So there was a big European-wide project, lots of contributors, utility companies, there was some financial service companies, universities, all kinds of companies looking essentially at smart cities and utilities and posing the question of what would a smart city look like in the future? What kind of data would exist on a smart city, a smart utility? What kind of services would be running? What kind of threat actors would be out there? So this was quite an interesting project. I was very fortunate to be pulled into this project to look at data security and data acquisition and data services. So I was given the task of looking at whether blockchain had any part to play in this kind of future world. And it was a fascinating few years for me. It was a 3.5-year project. I absolutely fell in love with the technology itself, but it was very, very difficult to apply it, particularly in a utility context, for a number of reasons. So obviously we talk about scale, confidentiality, all these kind of challenges that we know exist in this blockchain world. But integration, working with traditional languages. I'm a .NET guy. I want to work in .NET. What blockchain can I use? Well, not really too many choices. I mean, there's Stratis, Neo, and there's a few out there today. But certainly back then there was less choice. So that's where I had my baptism into blockchain, and that was the impetus from that early research project with a number of partners for Atlas City. So Atlas City really was going to look at how we can build a blockchain, and not just a blockchain, but a family of technologies which would enable businesses and government agencies and financial service companies and all kinds of users to actually become participants on these kind of networks. So how can we make and build a practical network? So this led ultimately to the concept of Catalyst, which is what we'll talk about tonight, and it was also what led to Atlas City, which is today Atlas City Global. So shall we go on to the first slide? Okay, so this is kind of related to the challenges which I was referring to. So when we were looking at how you can apply blockchain, of course we have many of the challenges we're familiar with. So these are some of the points which were of real concern to me at the time. So we needed something which was fast, and I don't really like the term fast. I mean, essentially it's high throughput, and it's not really about speed necessarily. It's just about being able to handle volumes of data. So at Scottish Water, for example, which was one of the partners in this particular project, they needed to support 2.5 million smart meters. So how can we make sure we can generate writes every 15 minutes from a smart meter? Hong Kong is the similar size. We did pilots in Spain, Portugal, Czech Republic. So speed, and then specifically transaction throughput. How can we handle that volume of data? Accessible, so we had teams working in .NET, we had C++ teams. You know, if you're a utility in your business, you've invested heavily in learning a family of technologies. You don't want to have to ditch that family of technologies or retrain your staff. You're heavily invested in technology. So accessibility is being able to use your Visual Studio, if that's what you're inclined to do, or whichever language or framework. Democratic, so there's obviously, we always talk about this problem of as you scale a network, it becomes less democratic. Well, we needed to be able to be confident that if we're doing a public network or we're doing even a large private network, that there is an element of democracy in there. Otherwise, we might as well stick with a centralized solution. I mean, cloud computing is very good at doing many of these sort of large-scale utility systems. If we want to use blockchain, we want to keep it democratic. Integrated, we have to work with quite legacy systems. I mean, we're doing work at the moment with a port operator. It's amazing how old some of these systems are. And we have to be able to integrate with them. So that's a real important consideration. It's got to be light, and by light we mean it's got to run on very low resource devices. If you're working on a smart meter, you have very little memory, storage, very little compute. But you need to be able to do hashing on there. You need to be able to make the most use of what is a very limited piece of resource. And then security. Of course, security is always really important in any system. And it's not just security. I mean, it's confidentiality, it's privacy. So it's all of these kind of things which you need. We were engaged with the Bank of England for a period, and of course, then they were very keen to make sure that we had a practical solution we could apply to keep transactions and financial accounts confidential. So we were engaged with a lot of companies who were telling us, these are things you need to be able to show us that you can do. And we're not interested in telling us that the industry is working on solutions to these problems. We want to know that you've got a strategy to deliver this, because why would we adopt something if we can't be confident that there is some solution within the next few years? So Catalyst, what is Catalyst? Well, Catalyst is not a blockchain. So I'll make that clear now, because blockchain is very, very important. It brings many benefits to this kind of industrial system we were looking to build and implement. But it's not just about blockchain. So we needed to be able to actually serve a few different layers. So Catalyst is actually a stack of 6 different layers of technology, and they're not all completely ground up, written by us. These are the layers which we're heavily involved in supporting. So user interface, we have a wallet for being able to interact with the Catalyst network, but it also works with other blockchains, Bitcoin, Ethereum, and so on. But user interface isn't just wallets. I mean, that can be, user interfaces span desktop software, it could be computer games. We're working on some interesting projects, including a project in recycling. We have representatives here from that company. Fascinating project, but it's essentially how you touch the user, how you interface with those users. Now, very importantly, it's not just about us being able to build these layers. What we're actually looking for is people to help us to work in many of these layers. So user interfaces, we have decentralized applications, and so dApps, and that's smart contracts. So it would be your traditional EVM if you're in Ethereum, but again, we needed people to be able to build dApps in any language or framework they want. They have to be agnostic. You've got to be able to run business logic written in C#, for instance, or in even in assembler. We have people who actually still work in assembler need to be able to capture some of this business logic within a dApp. So that was a requirement. So we have our dApp layer, consensus. Now we have custom consensus module here, but Catalyst is actually very modular. So we actually have 2 consensus mechanisms at the moment. We have our own POA, so proof of authority, but we have our new consensus mechanism, which my colleague will talk about a little bit more later, and that's really for the public network much more. We have the distributed ledger layer, so that's where we start to get into blockchain. So that's essentially how do we capture structured data, so tabular data. We have distributed file storage, so if anyone's familiar with IPFS, these kind of technologies. So this is really important because if you look at something like a utility, those data concentrators, they actually create batch files, quite large batch files, and you need somewhere to be able to store these batch files. So we've got to be able to work with not just structured, but unstructured data. We're working on some interesting projects where we have to capture photo and video. So we've got to be able to handle all kinds of data. So this is a really important part of this stack. And in fact, what's really I found very interesting is once you integrate distributed file storage into this kind of stack, you actually get benefit within your consensus layer. So when my colleague Pauline talks about this later, the consensus module we have could not work if we didn't have distributed file storage. It's a really important part of this woven in set of layers. And of course, the peer-to-peer network, which you need for any kind of blockchain or DLT. So user interface, as I mentioned, I won't spend too long on this, but we have our wallet, but we also have a number of user interfaces being developed with partners. We have partners in supply chain. Did a really interesting project last year, which they demonstrated at a conference in Amsterdam, and that was really just showing how you can track and trace real data. It was a fascinating project because they were it was a spin out of a very large global logistics firm. So they had live data they actually had coming in from vehicles in transit. And so in that case, they were a C++ team. They wanted to work with C++. So within 2 weeks, as I recall, and I hate using that term too much because people can hold you to this idea that you can build a very feature-rich DApp within 2 weeks. But in that case, they did build a very functional DApp within 2 weeks, in which they demonstrated. And we're working on some applications now with some other partners. Smart contracts. Now, this really breaks down into, we have 2 modules at the moment for supporting dApps. So we have the KVM. Now, the KVM is essentially, that's work we're doing at the moment on kind of a port of EVM. So the idea that we have KVM is there's a nice migration path for people who've already invested time in Ethereum. Maybe they've written some really interesting dApp, they're hitting some performance problems, they want to run a private instance of Catalyst, or they want to deploy onto the public network, maybe to access some of our other customers. So it creates them a new opportunity to be able to run their application. So that's KVM. So that's quite familiar. So that's really for managing the global state machine. And we have DCS. Now, DCS is this distributed compute system. So this is essentially containers. Any process you can run inside a container, so you can build your applications, deploy it to the DFS, so on a distributed file storage. You can retrieve them and run them inside Docker containers, or not just Docker containers, but other containers. And they can in turn talk to the KVM for interacting with the global state machine. So it's an interesting way of being able to build very rich, non-deterministic applications which you want to run within containers, and where they need to interact with the actual ledger itself, they can talk to the KVM. And if you're just working with data on the DFS, so you just want to work with the data on the distributed file storage, or you want to interact with services running in the cloud, well, that's fine. You can work directly from DCS. And this was a really important requirement for us to be able to do that. Yeah. Okay, now I'll pass it on to the clever person here who really understands how the consensus works.
Thank you, Darren. All right. So I'm just going to give you go through a few slides, talk about the inventions behind the challenges that the research and engineer team have faced trying to solve the so-called blockchain trilemma. So how to manage a distributed ledger that would be decentralized, accessible, and secure as it scales. So perhaps the first thing to note about Catalyst distributed ledger is that, as Darren said, it is not a blockchain. And as such, the first way around the scalability challenge was to remove the very concept of UTXO. So for those who are not familiar with blockchain, a UTXO refers to unspent transaction output. So it's when a transaction is in a block, ready to be spent, when an output, is ready to be spent and unlocked, and becomes later on an input to a later transaction. So what we decided to do was to remove that concept and focus on the idea of having digital account that would allow you to store different type of assets, different tokens, but not lead to the bloating or excessive size of a ledger. So we designed a new structure of a transaction which had the particularity of being quite compact and allowing you to handle different type of assets without having to distinguish so much between the type of account that you would have. So as such, we can have confidential transaction and non-confidential transactions. So Bitcoin, for instance, has non-confidential where you can, of course, you obfuscate your identity, you use pseudonyms, but you can view the amount that you're exchanging. Confidential transactions, such as the one that you can have on Monero blockchain, also obfuscate the amount. So we decided to allow both because we didn't see a reason to force any user to choose between the type of account they would want to have. We also obviously have transactions that are, or accounts that are smart contract based. Another aspect of the transaction is that we stopped thinking, the reason why I say no more UTXO is because we stopped thinking in terms of input, output, we start thinking about transaction entries. So it didn't matter if you wanted to spend or if you wanted to receive, what matters is that you wanted to participate into an exchange of assets. And as such, by stopping the distinction between the spender and the receiver, we would also improve your anonymity by obfuscating the role that you take when an exchange takes place. All of this is permitted through the use of an aggregated signature scheme, which has a major benefit of allowing you to have a faster verification time, especially when you deal with a large transaction volume or bigger transactions themselves. If you could move that, thank you. So as a result, if we forget about keeping blocks of transaction, but using this transaction to update the state of an account, we no longer talk about blockchain or block of transaction. We talk about ledger, ledger state, and ledger state update. So the way, and I will talk a little bit to you about the consensus, the way that our consensus mechanism operates, it's allowing the database or the ledger state to create updates, small updates of the account that are impacted by a set of transactions during a short period of time. So some nodes, not miners, we no longer call them miners and you will see why, we call them producers, are tasked with agreeing on producing ledger state updates, the equivalent of a block, that as a result, update our database. As I mentioned, the Catalyst database itself has different compartments or partition that allow it to store different type of accounts. And each partition state is updated as what we call each ledger cycle. I will go a little bit further about how you reach to that agreement of a ledger state update. But what matters is that we reach in a very small amount of time. We're currently experimenting between 30 seconds, or actually even 15 seconds, and 1 minute. The producer nodes produce a block or ledger state update that they can append and distribute to the user in the network that they can use to synchronize their version of the ledger state, of the current ledger state. These blocks, the recent ledger state updates, are typically stored by every user node, while the older ones are not, are deleted and kept by a smaller fraction of the network, certain nodes that have an installed instance of what we call our distributed file storage system, DFS. So you can see here, for instance, the current ledger state at the top. The second layer is the recent ledger partition state updates that are kept by all. And if we go to the next slide, we can see a global view of the distributed ledger, of Catalyst distributed ledger, where you see the bottom is the specific historical updates, as well as any big files or smart contract files that do not necessarily need to be used by all or be accessed at immediately. So I guess the way we reach this, how do we manage to have a compact distributed ledger, is by making a small trade-off. You can access any recent activity immediately, and anything that's a bit more complex or a bit older, you might have the small trade-off of waiting, requesting it from specific nodes, which allow you to still do some audit or any sort of fact check that you wish to do, but allow you to keep the database pretty small. And by pretty small, I don't mean just a small gain. If you think of the Bitcoin blockchain, which currently is around 225 gigabytes, for, I think, around 50 or 500,000 unique Bitcoin addresses, for the same amount, we are aiming around less than 1 gigabyte. So that's actually quite nice, because 1 gigabyte can sit on many computers, including our home computers, which is allowing us to reach to what Darren was mentioning as a democratic state. So that led me to the consensus, actually. So I am going to go over some detail. We have worked hard to produce some solid documentation. No way I could do that now, and that would be confusing anyway. It would be unpleasant to see tons of formulas. But to give you an idea, so we studied the different consensus that existed, the different consensus protocol that existed, and although we appreciate the groundbreaking work that was done, there were some inherent flaws that came with proof of work, proof of stake, and namely, the main thing was the lack of opportunities for modest nodes, and the second big problem was the tremendous amount of energy wasted to provide security. So the concept of a secure ledger was absolutely coherent, but the concept of wasting more energy than Switzerland for Bitcoin and Ethereum in a year time didn't really convince us. So we went for an alternative, and we realized that we could take, actually, rather than seeing the scaling of a network worldwide as a problem, we should take it as an advantage and accept the diversity of nodes that are joining us and take advantage of the plurality of resources available. So what we decided to build is what I would call more of a decentralized voting system, where there's no real computational hard problem like you would find in proof of work. You achieve consensus through a collaborative work. So you require nodes to agree to provide a bit of work each and to agree on what would be a coherent truth. They have to reach a truth by finding the same set of, agreeing on the same set of information, and you need a majority of those nodes to do so. It also has some nice features, such as an improved privacy, in the sense that, as I mentioned, the transaction entry no longer distinguishes between sender and receiver. Moreover, we shuffle all this when building our ledger state update, which means that you can still audit and prove that you participated in a transaction, but if you wish to, if you don't have to, then you can better hide what you actually did with who and when. There's also a concept of fair retribution. What we should value in a network is the amount of resources you provide to it. And if you wish to contribute, you should be entitled to do so, not because you have invested into a very heavy computer, but because you have some resources to provide. And as such, you should get retributed for that. And there is also an element of, obviously, extra security. You have to make sure, obviously, you're secure. And in the likely case where you have tons of nodes who wants to participate, this is actually going into our advantage, because you can do a random subselection, which allow you to even better secure the network. So I'm just going to go through the phase, but quite briefly. So the way we've designed it, we've just split it into 4 phases, like a decentralized voting. So you just have to imagine that you're going to vote for an election, but in the end, there is no such thing as a ballot counting in a central situation. So first, you start by constructing. So you first have a subset of nodes that collect transaction, and each of them creates a local ledger state update for that specific cycle. Then the next phase, they create their candidates. So they find out what is the most popular legislative update between themselves and create their own candidate. And then they vote on the candidate. And finally, once the vote has been agreed, there is the concept of nomination. So you reach an agreement. There's a nomination of the approved legislative update that is propagated across the network and quickly updated by the node. The update itself is stored on our distributed file storage system, so DFS, and distributed to all nodes for swift synchronization, and so on. And the triangle you see is this the representation of the accumulation of transaction in your mempool, while all of this is happening for the next cycle. Yeah, I'm done with the technical.
Okay, there isn't too much more, so don't worry, the pizza won't be totally cold. It's important actually just to mention that the technical papers are available. I don't think they're on the website yet, but for anyone who's interested, there is some very detailed papers on the consensus mechanism, what's been set out. And it's been reviewed by quite a few people, including getting legal review. So if people are interested, just speak to myself or any of the Atlas team. We've got the shirts with the logos on. But okay, the roadmap. So 2017, this is where the journey started. I won't really spend too much time on there. We raised the initial investment. So our original investment actually came from the oil and gas industry. So US oil and gas was the source of our funding, allowed us to get the team assembled and to open offices here. And it's because they are a typical industrial user, high value data. They were very interested early on in the application of blockchain. But of course, again, it's volume, it's confidentiality. So they were looking at this already, and they reviewed the early papers, the early work, and they were very keen to just get behind the company since there's a lot of synergy between what we were doing. So that allowed us to get started back in early 2018. We very quickly built a prototype network. So the original network was written in C++. It was a throwaway prototype, but it was to test some of the ideas we had. We had the funding, we could get the engineers, we could build a very rapid prototype. And with that, we had partners actually run their own POCs on there. Not just in oil and gas, but as I mentioned earlier, in supply chain. We learned a lot of lessons from that. It was a very valuable time for us as a company. It encouraged us that we were on the right track for what we needed to do for industrial settings. And so then we proceeded to actually focus on the full commercial enterprise system, which is what we've been doing. So there were patents filed. Now, these are generally defensive patents. I mean, in this, it's very important. Ultimately, we want to build a public network, and that means a foundation going out, and it's all got to be open source. And of course, if you've got an open source project, it's arguably what's the point of having a patent? But then that patent's really more for defensive purposes. So within the public network, the foundation, we anticipate that people will be forking, contributing, and so on. There's been further follow-on investment. There's been a lot of publicity recently, in Sky News, and where Sir Mark Weinberg, who's our chairman, was speaking about why he has got involved in the company. So people probably aren't familiar with Sir Mark Weinberg, but he is one of the founders of St. James Place and various other insurance companies. Very big name in the city, particularly in the insurance space. And it's because he took real interest in what we were doing in oil and gas, and he was interested to see how you can apply it in insurance and financial services. So he is now very much involved in the company, as are a few more people. And he's helped us to raise follow-on investment. So we've done quite well for a London firm. We're not a Silicon Valley firm. And I hear things are much easier out in Silicon Valley, but we persevered. So where are we now? Okay, open sourcing. So we're planning to open source. Now, the original plan was actually to open source at the end of July, and there was a lot of discussion as whether we should do that. Now, we're actually doing a two-phase open source. So at the moment, we're doing kind of a sort of an invite or an application-based process. So people who want to get involved, want to come and have a look at the code, want to contribute. So we're working with companies like Deloitte Blockchain. You're working with external partners who have got a genuine reason to be looking at this technology, because we want people to validate, more and more people to validate and decide if this is a project they want to get involved in. So this is a phase one. This is running now. We have a few people are getting involved, and it's growing all the time. So I'm finding it a very exciting time at the moment because we're getting that feedback. The intention is to build a community, so people who are feeding back, and then they can start to build their own apps and their own wallets and their own services. And more importantly, they can start to contribute to the core code base. I mean, ultimately, the people who are getting involved now are going to be the leaders in the public network and ultimately the foundation and that core team. So as soon as that community feels it's the right time to fully open source, now for myself, I'm hoping that's the end of August, but I don't think it's right for Atlas City to determine that. It's going to be up to that group of companies and academics to decide. That will signal the full open source, so hopefully not too far away. And then we have the first cohort following on from that. So the first cohort is where we work with our current and new investors to essentially create a fund to help people to build applications on there, build services around there. And that's really important because I think we've built a lot of expertise within the company and we're working with various consultancies and third parties to try and bring them up to speed with where we are. But we need to make sure there's funding available for companies and startups and individuals to really make the most of what we're doing. So we'll provide access to SDKs and expertise. They can join the Slack channels. When we have the first cohort, we'll have stand-ups in there. So the idea being that potentially weekly, we would have a weekly first cohort meeting. So it's a chance for people to talk with all of our developers and people can start to take more shared ownership of this technology. And so that's partnership building. And then Q1 next year is full public launch. And essentially full public launch is when do we launch the public network? And again, that's really important. It's driven by that community. So the public launch of a network, everything will be open sourced, everything will be out there, all the papers will be published, and it won't be Atlas City leading to that time. So what's Atlas City's long-term business plan? So Atlas City will be the same as any other company working on the Catalyst network. We built the Catalyst network because we needed it to be able to build the applications we wanted to build for industrial use cases. So Atlas City will go off and build actual use cases, build applications. We will continuously be part of that core community. We're not leaving that core community. We have a lot vested in that technology. But it will be open source. It will be community owned. Some of the people, now I think we're probably about 25 people at Atlas City, maybe just 23, 25 people. So not a huge team, but not a small team. You've got myself, Chris Justice, who's a co-founder. He was COO of Janus Henderson, so large asset management, I think about 400 billion under management. So he's our COO. He's got a great history of building companies, including at least one company listed on NASDAQ. And so a wonderful background. We have Joseph Christopherson just behind me, so Chief Marketing Officer. And we have somebody else coming in to work with Chris as well, who was from Facebook, so sort of more of a Facebook background, was very involved in their CMO kind of position. So we'll be working with Joseph. So we'll have a good solid team, marketing and PR team. We work with external agencies, Luminous, fantastic PR company, plus a marketing company, Relevance House over in Switzerland. So Dr. Pauline Bernard, R&D manager, so leading the R&D team. So that's coming up with all these interesting ideas, papers, and challenging some of our preconceptions of what we need to be building. James Kirby, who's the head of engineering. I think James is probably here somewhere. But most of our team, as a company, we're engineering heavy, which I think is right for this sort of technology. We have a good engineering team, a lot of senior experience in that team. And it's really split between R&D and engineering. Yeah, is that? So thank you very much. If you have any questions as well, you'll see people with these Atlas City shirts on scattered about the place, mostly engineers, so we'll be able to answer technical questions. Not everybody in the company is wearing the logos, so, but that's, I'll hand it over.
Well, hopefully that gave you some insight into the innovations that have gone into developing Catalyst and why we think it's special and why we've developed it, and also the bit of the history of the company and how we got to this stage. So I think for those of you who've got any questions, want to understand a little bit more about what it is that we're doing, where we want to be building applications, where we see the future of Catalyst. We can do a quick Q&A session. I know that it's getting kind of late and you don't want to be spending too much time, but for those of you who are curious, we're happy to answer any question goes, really. We work at good at a lot of things, but capturing audio is one of them, so we have to kind of hold this thing. So yeah, I'd like to open up to the floor if you've got some questions. Yeah. Just hold this. Sorry, I know it's a little bit.
Could you expand on the producer award and how the similarities or differences between that and a miner's reward?
Sure, I think so. So, you know how if you're a miner, you're going to spend most of your resources not so much validating transaction, but finding the solution to the cryptographic puzzle. So basically, based on your hash rate, you are more chances to win, and if you win, you will collect all the new Bitcoin or new token injected at the end of a certain period of time. In the consensus that we designed, it is not one node that collects, so there could be new token injected. It could also solely be transaction fees, or at least in our model, there is a concept of newly injected token. Now, it's not one node that collects all the token. It's all the nodes that were contributing to this voting system, so all the electora, if you wish, that is going to share those tokens among themselves. Now, you can foresee a situation where you have some nodes that have different amount of resources, different CPU, different RAM to provide. Now, you can also imagine how it could be beneficial to split pool of resource, pool of nodes, so that some nodes that have more resource can be tackling more challenging work than others that are more modest. But all of those should get a reward that is based on the amount of resources they can provide. So it's quite different in a sense that you don't have to solve something complex. It doesn't matter if you have more power. It doesn't matter. There's no hash rate war. Of course, we should take the available or the diversity of resources. We should take that into account because it's good to have very good computer, and it's also good to have a home computer. And then take that into account and manage the variety of work. Some of you maybe do 3 transactions a day. I know I don't do that many transactions a day. I take the tube, maybe buy a coffee on my lunch, and that's it. Some big companies are going to do far more than that, and some of us are completely hooked on the card. So, we should take the variety of activity and the variety of resources available, and then make sure everybody gets a fair share.
Sorry, I think you had a question next. I'll get to you next, James.
Hello. You talked about Atlas City being involved in oil and gas industry. What other industries do you think this is going to be relevant for?
To be fair, I think it's actually relevant to all industries. But I mean, there's certain industries we're focusing on just because we've got better connections into those industries. Obviously, oil and gas, since that's where our funding comes from, so we've got naturally good connections. Water utilities is actually the next one because I've got a background in water utilities in particular, so we've got some really good connections there. So there's a project called Urban Water. So this is being updated at the moment to run on the Catalyst network, so water. Supply chain as well. Supply chain is one. I think as a business, we're trying to avoid the ones which are most understood. So supply chain, we all know supply chain is a fantastic use case for provenance and being able to do tracking. My personal favourite is recycling. There's a recycling project we're in because I just find that a fascinating project, not just in terms of the technology, but of course the environmental impact. I think it tells a very positive story. we're trying to be very environmental as a company. I mean, we talked about making sure that the consensus is very lean and efficient, and that's really important. In fact, we talk about trying to create a carbon negative network, or at least a carbon neutral. And when we talk about that, it's because on a public network, there's the opportunity there to create some kind of maybe green tax, which can go towards carbon offsetting. There's lots of things you can do. And there's been so much bad press against blockchain, particularly things like Bitcoin. You know, I'm a big fan of Bitcoin myself. I think it's really had a massive impact on industry. But if you scale it up, it's just not practical. And I'm a bit of an environmentalist myself, and I just think the trade-off is not worth it, not for me. So I think being able to do consensus in ways which is more efficient, and then look at carbon offsetting and see if you can make a network which is actually carbon negative, the more it scales, I think that's a fantastic challenge. But in terms of industry, any industry.
Yeah, sure. I'll add a little bit to that as well. I think overall you can like generalize the application of blockchain to so many different things. That's one of the interesting things about the space, I think. But I think more specifically about Catalyst, what that provides by having this quite lightweight architecture and allowing multiple plurality of nodes to access the network. You can have really small devices now operating as a node and connecting to the ledger. So that opens up a whole new world of like machine-to-machine communications. Because when you couple that with like an automated smart contract, when certain conditions met, this device or whatever will just send a transaction or an action to another device. So it opens up a whole new world of machine-to-machine communication, and IoT kind of space opens up then. And when you couple that with all the industries that are now entering new areas of IoT, where the oil and gas have quite large networks on their oil rigs and things like that. So I think just the proliferation of IoT coupled with like a lightweight structure like Catalyst, it kind of marries quite well. So I think the machine-to-machine is probably a big area, but it's not an industry necessarily. It's more like a kind of a tech trend. But that's just one thing I'd like to say to that. Do you have a question there, James?
I'm just going to add one thing to that. I read an article recently where they said one of the flaws with blockchain is today there's more bots creating transactions than humans, so clearly the technology is broken. I don't think that's the case, actually. I think it is just a trend. It's inevitable that bots will outnumber humans in time. So it's not a flaw in the technology, it's just an evolution of industry.
Yeah, definitely. So there you go, James.
Thank you. Thanks, guys, for the talk. Really interesting stuff. I just want to defend Bitcoin quickly and say that about 75% of the energy used for Bitcoin is actually renewable energy, and as well, a lot of that is load balancing. The extra 25%. So, I don't think Bitcoin is killing the planet. I think it's a bit of like a fear and fear line from the journalists. But that wasn't my question. I mean, the reason that Bitcoin needs to burn so much energy is to maintain decentralization. So you've got a really interesting proposal on the consensus mechanism. But my question is, how do you qualify a node, and what do you mean when you say a majority, like a majority of compute power, or in terms of number of nodes, and then how do you qualify the node?
Thank you. So how do you reach majority? Of course, you could just say you have to have 50% of the nodes. So say that you have a set of nodes and say that they are managed by or listed on a distributed hash table and managed. So we know who is currently in charge of producing the legislative update for one cycle. You could say 50% needs to be the majority, but 50% is very close to what if you have 50% malicious nodes. And so I guess it depends what sort of threshold of security you want to achieve. Like talking about Bitcoin, I understand. I think there is the problem of how do you make sure that no matter what you produce, you know that there is no majority of nodes that are going to affect the communication of what's the correct next block or what's the correct legislative update. We use math, and we use math in a probabilistic approach. So yeah, we rely on numbers, we rely on high numbers, we rely on a lot of nodes joining the network. The more nodes, the better, because as statistics tell us, the more nodes, the more you can trust a result, and it won't be 50%, it'll be more than that. but that will be dictated by basic mathematics. I come from a physics background, so I don't know if you've heard of the Higgs boson discovery. It's not that you find the Higgs, it's that you define a method where you know by 99.999% chance that there's no way you got it wrong. And I think that's the approach we're taking. With my scientific background, I hate saying that it's 100% sure because nothing is. So all I care about is making sure that it's not that I'm 100% sure, it's that I'm 99.99% sure that I'm not wrong.
That's good enough. Is it one node, one vote then? Like a registered
Yes, it's one node, one vote, depending on the pool you join. So you ask how can you quantify, how can you decide? So you want to know what account you're dealing with, so what sort of activity you're dealing with, and then you need to provide proof that you have the computing resources to participate, to handle that transaction throughput, or more generally, that amount of data processing. And then you can join, and then yes, it's equal. So obviously, there is also a peer identification protocol, so it's not to disincentivize people to have more than one node, but you can have more than one node, because after all, you could have several nodes in a house, and that's okay. But there is an inherent concept of allowing anyone to join. So that's why I mentioned briefly that you also have the concept of a random selection. So it wouldn't be that easy for anyone to spin up 1,000 nodes and try and get control over any pool. There is a concept of queuing, of tertiary queuing, which is good for us as well, because it's regulating the level of activity, the demand and supply for work, so making sure that there is no suspicious activity, and at the same time, if there is a lot of demand, we can regulate that, and if there is not enough, we can encourage newcomers to come and contribute. So,
Right, thank you. Does anyone else have any questions? Okay, no.
pizza time.
It's pizza time, I think. On that note, thank you all for joining us this evening. Cheers.